everybody, and let's start another solving problem under vapor cycle of thermodynamics and heat transfer. So this is our part 2. For our part 2 problem, we have increase the boiler pressure of. So if you have watched my previous video under vapor cycle, we have a part 1, so that's example 8.1. So here in this problem, let's increase the boiler pressure to 4 megapascal while maintaining the maximum temperature and the minimum pressure. So on our previous problem, stated there is our maximum temperature and their minimum pressure. So in this problem, instead of answering those questions again, let's have we are tasked to calculate the percentage efficiency of the boiler. So neglecting the work of the pump, we have here the specific enthalpy at the second process to be 192 kilojoules per kilogram. Stay tuned. And at 400 degrees Celsius, that is our we just increase the pressure of the boiler, but the temperature remains the same, which is 400 degrees Celsius. So at 4 megapascals, if you have your property table, please locate this. At 4 megapascals, our specific entropy to be 6.7698 kilojoules per kilogram per Kelvin, and for our specific enthalpy to be 3214 kilojoules per kilogram. So we're solving for our quality X at process 4 at state 4. Plugging in the given values needed in this formula, we now have the quality X at our state 4 to be 0.8159. Let's proceed in finding for the specific enthalpy at state 4. So plugging in all the needed values in this formula, we have 2,144 kilojoules per kilogram of specific enthalpy at state 4. So the heat addition in our boiler is equivalent to the difference between the state 2 specific enthalpies to state 3 of the specific enthalpies of our boiler. It is solved a while ago. So we now have the heat addition to be 3022 kilojoules per kilogram. For our turbine work output, still the same, but we're going to use the output for the output since it is output. So it is our process 3 to 4. This is our turbine. So for our specific enthalpies at state 3 and 4, you just have to subtract both and can get our turbine work output to be 1070 kilojoules per kilogram. Next up, for our thermal efficiency, this is the formula above. This is equivalent to the differences on our work input and the work output from the turbine. So our thermal efficiency is 0.3541 multiplied by 100%. We have 35.41 thermal efficiency in our boiler. So this is it. Our thermal efficiency a while ago is 0.3541, and our previous thermal efficiency on our previous problem, we have 0.32.32. For the percent increase, since we need to calculate for the increase in the efficiency of the boiler at increased pressure, that is 4 megapascals. So this is the formula. We need to subtract both the efficiencies all over the initial or the first efficiencies to be 0.3232 multiplied to 1000 So we now have the answer, or the percent increase in our thermal efficiency of the boiler to be 9.55%. So that's it for part 2 problem under thermodynamics and heat transfer. And thank you so much for listening, everyone. I hope you understand and learn from this video. See you in our upcoming videos to come, and good day and have a